This is Module 25 of Engineering Vibrations and Introduction to Single Degree of Freedom Systems. Today's learning outcome is to plot and interpret the transient response solution that we've come up with for a simple single degree of freedom system undergoing free underdamped vibration. So this is where we left off. This was the response solution that we came up with. Here is the DEOM that I've written earlier. I'm now going to come up with what I'm going to term the standard form of the DEOM, or differential equation of motion, where I make the coefficient of the acceleration term equal to 1, or unity, by dividing the whole equation by m. So what I end up with is y double dot plus c over m y dot plus k over m y equals 0. And by doing that now, I can use this critical damping ratio expression to come up with what C over M is, which is 2 zeta, the critical damping ratio, times the natural frequency, and K over M is the natural frequency squared. So in that form of my differential equation, if I have actual numbers, I'll be able to easily determine what the natural frequency is and what the damping factor, or the damping ratio, is, zeta. So here is a plot of the underdamped solution for a given set of parameters. And I've given the system an initial displacement here, shown as y0. And since the system starts with a positive motion upward, I've given it a positive initial velocity. And this system is any typical underdamped system. Let's take, for example, let's look again at the video of my golf cart demo. And in that video, you can see that the suspension system, the golf cart, goes up and down and dies out exponentially. So you can see that there's a period of oscillation between the damp period of oscillation for a complete cycle, which is longer than the undamped period of oscillation, since the damped natural frequency is less than the undamped natural frequency. And you can see that we have this exponential decay envelope. And so that comes from this term in front of the brackets. What's inside the brackets is just an oscillation motion, but it's being acted upon by this decaying exponential envelope that forces it down. And so that's an interpretation of the response solution for an underdamped free vibration system. And so with that, the summary is that we've plotted and interpreted the transient response solution for this simple single degree of freedom system undergoing underdamped vibration. And we'll move on from that in our next module.